begin with the questions from the people. I actually have some questions from some partnering societies. So first up,
Okay.
we have some questions first up from UCL Space. So it's the Space Society from UCL, and the first question they have is, if NASA received the same percentage of the national budget it had in the 60s, what do you think modern aerospace would look like today?
It would be a lot different. At the height of Apollo, the NASA budget was roughly 1% of the annual budget, and it stayed that way through the end of Apollo. Today, it is less than half of 1% of the national budget, and it's going down. I really think, and even when I got to Washington after I had left Apollo, and I was the head of legislative affairs for the agency. Why they got an engineer from Texas A&M to do that, kind of hard to explain. But I was working the Hill. I was working the Congress, and I kept trying to make, if we could just keep something like 75.75 or 1% of the national budget, we could do amazing things. This thing, we would have been to Mars already, I'm convinced. But what happened is when we started Apollo, we had a balanced budget in this country. We were not running a deficit. And so we started from a great financial position for public funding. By the time we got to the end of Apollo, the Vietnam War had taken its toll. We had a lot of campus unrest, civil rights. In fact, that's an interesting topic sometime to discuss, because I told somebody I have a twin brother that was flying in Vietnam, and I kind of missed his war because I was so busy with Apollo. Now, we kept in contact through letters because there was no email in those days. But I also kind of missed the story in a way, not totally, but I missed the story of the civil rights movements of the 60s, because I could only catch flashes of it. I couldn't focus on it because we were working 24/7, flight after flight after flight. Those Gemini flights, for instance, came every 6 weeks. So it was very rapid. But I think if the budget had just stayed anywhere near where it was, we would be much, much further ahead today. The other thing we should have done, and I think we all recognize that now, we should have built an international coalition earlier. We've got it now. The international partners are working together very well. We don't have China in it, and the Russians tend to go off on their own, although they're playing a pretty good role in the space station. So we've gotten kind of pretty good at dealing with them. But between the budget and if we had established those international partners a little bit earlier, I think we would, the answer to the question, we'd be a lot further ahead now than we are.
Yeah, about it, I also remember, for example, when I was in the conference, I was twice to the conference. And for people who don't know, NASA has this contest, a NASA Space Settlement Design Contest. And I remember in my first year of being at the conference, where you have to present your project, when I won the honorable mention, we were told to not, to cover our NASA logos, because it was some sort of a protest because of the budget problems. And NASA has, I remember, some issues with the administration. I think it was Trump administration, and they actually asked us to cover the NASA logos because they were protesting, so they could not appear as if they're funding.
Yes.
Yeah, so it was.
Oh my! I didn't know that one.
It was. I think it was 2017. 2017. Yeah.
I met you in 2019.
Yeah, and afterwards
yeah.
I did not win anything in 2018. Then in 2019 I went on with the first prize. And then the contest, which was founded by NASA, now it was for NSS, the National Space Society. Yeah, but I remember some problems with budget. Also, we have another question still from UCL Space. In your opinion, Mr. Griffin, are space agencies still competitive in the current space race towards Mars, for example, against private space companies like SpaceX?
Well, if I understood the question correctly, and you broke up a little bit there, but I think I understand. Going back to the moon and on to Mars is going to be a partnership. It's not going to be done alone. We can't do it alone, particularly Mars. And Mars, we're a long way from going to Mars because still got to figure out how to protect the crew from radiation. That's probably the biggest barrier right now to going to Mars is radiation protection. When you get out into free space, the gamma rays are so powerful, they're cosmic rays, and the human body just can't take it. And so they're working on all kinds of shielding. Turns out, by the way, just a side note on that, water is a good barrier if you can do it well. They're looking at a double wall spacecraft that you would fill with water from not lift off with it full, but on your way to Mars, fill it with the fuel cell water. And I don't know whether that'll work or not, but they're trying to think of all kinds of things. But back to your basic question, I think it's going to take a number of countries. I think ESA will play a major role. I don't think there's any doubt Japan will. Canada will be in there, I can tell you. Australia has just set up a space agency about a year ago. Never had one, and they want to get on with it. So, yeah. Now, did I answer the question, or did I hear the wrong question?
I think so. No, I think so.
Because you were broken up a little bit.
Oh, sorry, my apologies. Okay. Maybe the internet connection. Yeah, but no, it's fine.
Yeah, I think.
Go ahead. Sorry.
No, I'm ready. Far away.
We have some questions from a society from King's College London, KCLES. We have some questions from them. So the first one would be, how did you realize that this is something you wanted to make what was your job about? How did you decide to actually work for NASA and be an engineer at NASA?
I was in, as I had said earlier, I was in the Air Force, and I happened to be home the morning that Al Shepard, who was the first guy we put on one of the Redstone missiles, the little ones, and just lobbed them about 300 miles down the Atlantic. But I was there for that. And I hadn't gone into the squadron yet. And when I saw that launch, and it was black and white television, a little screen, I thought, that is it. That is going as high and as fast as you can go. So I want to be a part of that. I knew I was probably not going to be an astronaut from the get-go because I hadn't been through that test pilot regime that everybody they selected in those early years were test pilots. There was one of those, so it'd be futile. So I said, I'm going for mission control. And I had seen pictures of the Cape, and I thought, God, that'd be fun to be a part of that. So it literally was, when I graduated from college, there was no space program. In fact, my degree is aeronautical engineering because there was no aerospace curriculum. Nowadays, aerospace curriculums, when you get out of that, you understand orbital mechanics and how you get into orbit and get out of it, change it. So we literally had to learn it on the job of what an orbit was. I didn't even know, had to figure out how do you stay in orbit, what? Then it finally, and NASA, we had some physicists and astronomers that were in our midst, and they helped a lot because they understood the physics of the solar system at least. So anyway, I'll try to keep my answer short because I know I can see a lot of questions.
Yeah. One more question from KCL Tech. How many people does it take in total to be successfully in a complete mission for NASA? How many people work together for a mission?
Oh, you're talking about on the ground?
Yeah.
I assume
yeah,
that
on
question
the ground,
means
I think on
in mission control. Yeah, there's the positions in the control center probably number in the neighborhood of 25, smaller than you think, 25, maybe 28. But there are back rooms outside of that probably have 3 times that many. So that's 100 people, maybe 75 outside and 25 inside. That's 100 people right there. Now, that would be the number of people it would take per shift when it was high activity. Now, when you get to a space station operation where there's no maneuvering going on and it's going around in orbit, things are stable, that can be cut back. But for the launch phase and rendezvous and things like that, where you have to have ground support, you're probably talking 100 people, and maybe on that whole, I'm trying to think, that might take, in order to put 100 people in there, you probably get an organization that's got 300 or 400 people, probably 3 or 4 times that many. So that would be my guess.
Nice. Lucia, are there any more from societies? Lucia, are there any more from societies? Any more questions?
Lucia, you hear him?
Yeah, sorry, I could not unmute myself.
No.
Because of the fact that only Nikita is the host and I could not unmute myself unless he allowed me to. Yeah. Yes, we also have some questions, just some 2 quick questions from KCL Space before we begin with the questions from the audience, if that's fine, but they will ask the questions themselves if they're in the meeting now. So again, we have KCL Space.
Are they going to be asking in the chat? Or
Yeah. They no, they said they will ask now.
Do it via voice.
Okay, I don't see anyone from KCL Space yet, so let's go to the audience first.
Sure.
Oh no, actually, we have someone named Aditya. Sorry, I don't exactly know the name, how to pronounce it, and he has to be unmuted if you can.
1 second. Just Aniba or Verma? What's her second name? Bird 2.
1 second.
No worries.
Verma. Okay, yep.
Brilliant. Aditya, we've just...
Hi, am I audible?
Yes, good. You are on.
There you are.
Yeah, perfect.
Yes.
So first of all, I'm a big fan. I just want to ask you what kind of role the lunar orbit rendezvous played in bringing them back in the mission, and how the decision was taken to discard Earth orbit rendezvous and the direct method approach.
Yeah, what the question is there is, should we do an Earth rendezvous in Apollo and put the 2 vehicles together and go on to the moon, or should we do a rendezvous in the lunar orbit run? You know, let me say first, that was before my time. While I was still trying to get to the agency. But there was a pretty heated battle, as you probably, if you studied it, probably know that there were a lot of people that thought it would be much safer to do it in Earth orbit and not do it at the moon. But it worked out, I think, just fine. And I like say I was not a part of it. It was just kind of handed to me when I walked in the door. So my only study of it, I came to a quick conclusion. It works. So let's not argue about it. And but it was, and a lot of it depended on, I think, some of the early estimates of how much power they were going to have, propulsion power, lifting power, and all of that. I think there were a number of questions in that regard, and they were just trying to figure out, how do we do it? And it turns out, I think it was perfect. But the secret was the Saturn V could lift everything that needed to go to the moon with one launch. And I think early on there was a question, can we do that? Can you pick up a lunar module and a Apollo command service module and with just one launch vehicle and loaded? And sure enough, it worked out just fine. You must have studied it.
Yeah, a little bit on the side. So did it play a role in the way Apollo 13 turned out, like how we brought them back, how you guys brought them back? So
Yeah,
did it play a role in that?
Yeah, I think it did. I think, one thing about Apollo 13, and I mentioned it before, if we had to have an explosion, it happened at exactly the right place because we had a fully loaded lunar module. And we had talked in the control center, we had talked about using the lunar module as a lifeboat, but we never had simulated it. We just talked about, yeah, you got a lot of battery power, you got a lot of water, got a lot of oxygen. It could probably be a lifeboat if you needed it. That's about as far as we got. On Apollo 9, which we flew in Earth orbit, we actually fired the descent engine in a dock configuration, which we had to do for the PC+2 burn. And we just did it because the program wanted to do it, not thinking that we'd use it one day at the moon or to get home from the moon. But I'm thinking it was good that we did it because we knew it could be done. And then we had all of that. Your first impression would be we lost our oxygen tank, so the short consumable is going to be oxygen. We're not going to have enough oxygen to get them home. Well, it turned out that was not true at all. We had plenty of oxygen. Actually, we had a lot of battery power in the lunar module, but what we didn't have was water. And the fuel cells put hydrogen and oxygen together, and it puts out electricity and water, and that water is very pure. You drink it, you mix food with it, you cool electronics, radiators with it, use it for all kinds of things. We rationed those guys down coming home. They were only drinking about 6 to 8 ounces of water per day, and they got very, very dehydrated. And in fact, Fred Hayes, the lunar module pilot, got a very bad urinary tract infection. He was running a fever when they landed. So water turned out to be, we had about 16 hours of water left when they hit the ocean. So we didn't have much more water to play with. But yeah, it did play a role. The way we had the mission structured saved us in Apollo 13.
Thank you so much.
Okay, now I will start off with the questions from the chat and then with people with raised hand. So I will start off with a question for the chat, then with someone with a raised hand, then another question from the chat, and so on. So first, was Neil Armstrong stepping on the moon the factor which decided the winner of the space war?
It was the final factor, because even though we know now the Soviets had kind of dropped out because of their big loss, we still hadn't done it either. And so it was for sure when he landed, actually, I think when he landed on the moon was almost as important as when he stepped out. Because just putting humans on the moon, even in a spacecraft, was such an audacious and giant thing to do that it really, I think it was a great step. But Neil stepping out on onto the surface was probably the moment that people will always remember. And he was such a good guy. I was going to talk a little about him, but I ran out of. He was one of my. I'll take the opportunity right now. I can make it fast. He was a guy that you would want to know. He was very, very humble. Very. He was a quiet guy. And if you've seen the movie, The Last Man, which came out last year, I think. Don't believe the character that Neil Armstrong, how they depict him. They depict him as being kind of weak and wimpy. He was not that at all. He was quiet and reserved. But I have seen him in a room, a meeting of 100 people. And he would wait till everybody else almost had said their thing, and there would always be talking going on. And maybe finally in the back of the room, Neil would raise his hand, and whoever was running say, "Neil, you got something?" Everybody would get quiet, and they would listen to what he said, because every time he spoke, he nailed it. He made it right on the money. And what a great guy to be the first person to step on the moon. And so anyway, great guy, and yeah, a big moment when he stepped out.
That's absolutely amazing, and to listen to someone who actually met Neil Armstrong, that's mind-blowing to me. Next, we have a question from Oshin Vaz. If Nikita, could you please unmute?
Okay.
Come again?
Oshin Vaz, I think it is.
Oshin Vaz. Okay, there we go.
So if you could.
Okay, Oshin, yes.
Can you hear me?
Yes.
Mr. Griffin, first off, it is an absolute honor to hear you talk. I am a huge fan. Now, my question is in regards to the end of the Apollo project. Now, this is a very controversial opinion, but I remember in high school, my physics teacher once called the ending of the Apollo project to be the greatest squandering of scientific advantage ever, because we had the entire cosmos in our grasp almost. I mean, we had a moon. We could have expanded. I mean, ice was found on the moon just 5 years after the Apollo project ended. Do you agree with that opinion, or do you think the Apollo project terminated at the right time?
Well, mixed emotions. Let me give you a personal story. I showed that picture on Apollo 17 of Neil Hutchinson, the young guy that was going to be the shuttle flight director. And I never will forget this. This moment is chiseled in my brain. We had finished the mission at the moon. We had done trans-Earth injection, so we were headed back to Earth. And those coasting periods going out and coming back, except for Apollo 13, were usually very quiet and calm. So I took a calm moment. We were coming back from the moon on 17, last mission. And I never will forget, the guys kind of came up around, the crew was asleep, and they came up around my console, and they were just standing, and we were chatting, and I stood up, and we were talking about the future and so on. And I remember saying, maybe it's not so bad that this is the last flight, because 20 years from now, we're going to be on Mars. That was 1972. We didn't quite make 1992 to get to Mars. But I thought, and I really agree with what you say, or that opinion, because if we had kept going, we had it in our grasp. We could have done it. We had, and let me give you another example. We got to Apollo largely because of World War II. We had built a giant aviation industry. And and now we were building not only military airplanes, but commercial airplanes and so on and so on. So we had this workforce of engineers and tradesmen, craftsmen that could build and weld and so forth. And actually, we just kind of moved some of them right over into the Apollo program. So we had this new environment. The space was going to have to be, you're going higher and you're going faster, and you're going to be in a very hostile environment. You had to learn how to do that. But a message for all of you: the space business is still a nuts and bolts business. It's not a mysterious thing. Some of the places we're trying to go are a little mysterious, but the hardware and software that it takes to do it are there. So we had that database. At the end of Apollo, now we had not only that database that was still there, we also had a space-related database of people, manufacturers, folks throughout the world that had gotten on board. And then we went back to Earth orbit in the shuttle. And if we almost, I think, turned everything down at that point. Earth orbit is not easy. It is hard to get to Earth orbit. That's the first step you got to go through to get to the moon. But it's nothing like deep space. It's nothing like trying to operate in deep space. And so we should have gone on. But the earlier question that someone asked about the funding, it just wasn't there. And the commercial people took them a long time to start investing their own money, like they had in airplanes back in 1930s. And in fact, I can remember when I was director at the JSC, Johnson Space Center, I was always see the people that built the command and service module, Rockwell. It was then a North American Rockwell before that, North American before that. And they would come to see me occasionally, their leadership, and I said, why don't you guys spend some of your own money and get in the space business yourself? And their answer was always, oh, our stockholders wouldn't like that. It's too big a risk. So it took people like Elon Musk and Jeff Bezos and people that had some money to put at it. I've met both of those gentlemen. They're different, but they put their money where their mouth is, and they got lots of it. And Jeff Bezos, I heard him talking to a group of his employees. He's the Amazon guy he owns Amazon. But Jeff was talking to his employees, and he said, I'll remind you, this was the space employees, this is a for-profit business. I'm not going to keep putting money into it unless we can make a profit. And they're starting to show some now. But somebody asked him, a press guy asked him, well, how do you fund this? And he said, I sell $1 billion of Amazon stock a year to put into space activities. And so anyway, I think it probably took somebody kind of like that now the big companies, the Boeings and Lockheed Martin, they're getting it. They say, okay, we're going to have to put some of our money if we're going to compete with these guys in the future. And Grumman, Northrop Grumman, it is now, actually joined the the Blue Origin, the Jeff Bezos team, to build that lander. And of course, they built the lunar lander on the first one, so they probably are going to be damn good. And but I think it's a good point. We should have gone on. I thought we would. That's why at the time I wasn't thinking that bringing Apollo to an end was all that bad, because we were going to go on, but we didn't. Long answer.
But very interesting.
To be honest, I threw my physics professor under the bus, but it was actually me who said that. They squandered it. It was just, I didn't want to get you upset at me if you didn't agree with it. Thank you for your honest assessment,
Gotcha.
Mr. Griffin. It's been an honor.
Thank you.
Okay, we have one question from the chat from Rafi Dreyer. Do you feel the change in approach as to who the decision makers were after Apollo led to the shuttle disasters?
Probably not. In fact, it may have. And they're two separate accidents, so, and they have slightly different answers, I think. The Challenger accident is the one that when we were going up after launch, a seal between two segments of the solid rocket failed. And when it failed, hot gases coming out there, it's like a welding torch. And it ended up tearing up that whole end of the vehicle, and you had liquid oxygen and liquid hydrogen in those tanks, and all you got to do is put those together and you get the big fireball that we saw. That joint, the solid rockets that were on each side came in 4 segments. That was because those segments were poured in Utah, way out west, and actually transferred solid propellant, transferred to the Cape on rail cars, and then they were stacked. And they had to be stacked very carefully, and those seals, these aren't small, I mean, they were huge. That seal was always tough to make sure it worked right, O-rings and all that. The design, the initial design was marginal. It worked fine for 25 or 24 flights. But they were already working on a new design change. There was a lot made of the fact that it was launched on a cold day, and that the temperature was the primary cause. And this is personal opinion, Gerry Griffin. I think we would have lost that rocket on a 100-degree day Fahrenheit. I mean, we would have. I think it could have been a very warm day, and that was a bad joint. By the time they launched that morning, it was up to about 37, 38 degrees. It had been freezing down to freezing overnight. But that seal was very hard, and the design was such that it was hard to make sure you had not crimped one of the O-rings. And they fixed it. The design finally fixed, but the decision to go was not made from higher up. It was made down low, or it was made by the project manager that on the solid rocket, and he knew more about. I know him well. He's recently passed away, but named Larry Malloy. He got right through the coals because he said, "Let's go," and some people at the contractor that built those did not want to go. They said, no, we ought to wait and let it warm up. So that was not a case of decisions, I think, being shoved up to somebody that didn't know what they were doing. In the case of Columbia, we had a piece of foam come off of the external tank, a big chunk in it. The external tank, that orange thing that you see in, was like a thermos bottle. and it was covered with foam on the outside that was sprayed on about this thick. It was much tougher than the styrofoam that you see in a cup or in a cooler. And a big chunk came off and hit the leading edge of the wing, which was made out of reinforced carbon, which was about a ½ inch thick and was tough as a boot. And when I was out of NASA for that, in fact, I was in Washington and I got called into a news program on ABC, and I was asked if I thought the foam could have been a problem. I said, no, I don't think so. I don't think the foam's a problem. That reinforced carbon is like steel. It's heavy. I picked up a section of it once, hardly pick it up. And I don't think that foam would do it. Well, guess what? They took it to a place here in Texas, Southwest Research Institute. They took the amount of foam they thought was about the size because they could see the photographs where this chunk came off. And they calculated it was doing 800 feet a second when it delta velocity, change velocity. When it hit, guess what? It blew a hole in that reinforced carbon.
Wow.
And there was no way to know. You can't see the leading edge from the cockpits. You can't. There's no way to look back. And so they started re-entering, and it was always fine. But then the hot gases of re-entry were going into the wing and turned it in, and eventually that wing came off and the whole thing came apart. Now, that decision, the only decision you could claim on that one, that some people said, well, they should have done an EVA and gone out and looked at it to see if it had a hole. Well, for one thing, nobody knew for sure that even what it was for a long time. And then secondly, there was they hadn't trained, there was no way to do that EVA. They weren't prepared to do it. After that, they had an inspection that they actually put on the arm of the Canadarm, and they could go around and look at the leading edge of both wings and just look at it physically to make sure it was okay. We also never had another chunk of foam that big come off the tank. Chunks of that foam had come off on almost every flight, but little pieces. This was one time that a pretty good sized chunk did. So I don't think either one of those accidents were a result of decision making level. You might question the decision, but we call that in the States Monday morning quarterbacking. It's easy to call the play next time if you know what happened the first time. So, and I hope I answered your question. That's another long answer. I'll try to shorten them up.
Yeah, I think there are too many questions. I'm not sure we'll be able to go through all of them.
Well, we'll go for a while.
We have a question from Fiona McAllister, and she wants to put the questions herself.
Okay.
Nikita, could you please unmute her? So it's Fiona McAllister.
Hiya. Hi, I'm Fiona. First of all, I want to say thank you for hosting this talk. It's been an absolute delight. I've actually got a couple of questions because my flatmate, unfortunately, he's not here, but he wanted to ask you a question as well, and they're linked. So one of the things you mentioned is that during the Apollo era, both sitting presidents were Democrats. Do you think things would have been different with a Republican president? And if so, what are the primary differences in the approach to space by the Democrats versus the Republicans?
Actually, both parties have been very supportive. Now, we've had different presidents that kind of had a blind eye, and I think they just kind of let their people handle it, and let somebody else do it. And then we've had some that have been very much hands-on, like Kennedy in the early days. And even Johnson, who came behind him, he was the first president I ever met, came into the control center. So the political parties were different. I do remember, you can feel the liberal conservative difference. I remember meeting with a senator, it's now gone, and his name was Metzenbaum. He was from Ohio, and the deputy administrator and I went to the Hill to meet with him, make a courtesy call, and I never forget, he was kind of a grouchy looking guy anyway, but I think he was okay, but he just looked grouchy. Anyway, we were talking away there, and we made our spiel to and gave him our spiel, and he looked at us and he said, "What do you think spaceflight can do for my people in the inner city of Cleveland?" I mean, that was his way of thinking, is that, and I could tell, and I knew we were barking up, as we say, barking up the wrong tree. That wasn't, we would never count on Senator Metzenbaum's vote, because he didn't think that you ought to spend anything on such silly stuff, that it ought to, go to socials and kind of hand it out. And we tried to make the point, that look, technology is, we're trying to push the envelope here, and the more we learn, the more we learn and we don't know. And of course you can't make, there was a lot of spin-offs from the space program, but you can't make the program stand on its own on that. Those are just good things to do, like our cell phone. Miniaturization of electronics really had to happen in the space business, and it taught us how to do it. So anyway, I don't think there's a lot of difference in the mainstream of both parties. I think they want us to excel. I think they'd like to see us have a robust space program, but it generally comes back to money, and that's why I'm glad to see the commercial people getting into it, because it does take some of the pressure off the government to fund everything. And I'd like to see commercial guys do more and leave the governments, plural, to look into deep space, the harder missions, the ones where you have to do new things. And that's what we ought to be doing. You had a follow-up question.
Yeah, so my friend Mo wants to ask what you think about the fact that the Biden administration is about to take the focus away from lunar missions and instead invest towards climate change. So he's wondering what your opinions on that are.
Well, I could talk all afternoon on that one. I won't, but I think it's a mistake. I think the small amount of money that we are putting toward, and I had a chart earlier that talked about stability. They need stability in funding. You can learn how to live with a certain figure and then maybe grow it at the GDP growth or something, but stay with it, just stability. If he comes in and turns down the lunar thing, now there's nothing wrong with using space assets to the extent you can on climate change. But if you just take the ship and say, okay, we're going to take all the load over here and put it all on this climate change side and kind of wipe it out, big mistake. Because we may not ever be able to crank it up again. I think what he's going to do, if you look at the details of his stated platform, is that he, quotes, believes in a lunar or deep space exploration, but, and then he puts the but with it, and so I think it's to be seen how much money do they take out of trying to get back to the moon, which is just a first step. Even Mars is just a teeny step in what we've got. And I'm going to take this opportunity to quickly give you a thought that I've had for a long time. Going to the moon was fantastic. In fact, that was 1960s. And trying to get back 50 years later, 50 years since we've been there, it's not going to be an easy task, but we can do it. And when it's all said and done, if you think of what we're really trying to do, I think one day we're going to have to get off this planet if the species is to survive. Now, it's not going to be in your lifetime, it won't be in your kids, your grandkids, your great-grandkids. It may be 1,000 years from now, maybe 10,000 years from now. But one day, and it's not climate change, we're just going to use it up. And we're going to overcrowd it to the point that, I don't know, maybe it'll fix itself with famine or something. But we're going to outgrow and outuse and use up this planet. We need to be thinking about how to move around out there. And I'll just say out there, if the species is going to survive. And this is just a teeny little step that we're taking. It's not enough in the big picture to even say much about, but if we don't start somewhere, we're going to sit here one day and 10,000 years from now, we're going to be used up and with no place to go. That's one reason the scientists throughout the world are looking at Earth-like possibilities that are out there. And they've found, there are billions of stars. And there's got to be someplace out there that's got some hydrogen and oxygen in the atmosphere that could sustain us. There's some places, good places that look good, but they got methane or CO2 for an atmosphere, so that's not going to work. So I really think that it would be a big mistake to take your eye off that ball too far. And I don't think they will. That was one good thing. One good thing about Pence is that Pence had the vice president. I think really dug into it and understood space flight and space technology. And this idea of going back, it wasn't his. It came out of the bowels of their administration somewhere. But when Trump put him in charge of it, Vice President Pence really dug into it and understood it. I hope if we'll put Kamala Harris in it, and she understands that, this is not just a bunch of guys going back to the moon. It's men and women. In fact, the crew that's going to launch day after tomorrow is a mixed crew. Got a woman and a black guy and an African American, I guess we're supposed to say. And but I hope if she can get in there, if she's the one, we'll all do our best to try to convince her that it's worthwhile.
Thank you very much.
That's my philosophy on the futurism.
Yeah, I think everyone here can probably agree with that vision.
Yeah. Good.
All right. Now next we have a question from the chat from Nan. So, hello, Mr. Griffin. Learning about spaceflight during the 60s to 80s were the true inspiration for me to pursue mechanical engineering. I have quite a personal question. What was the most important impact do you feel Chris Kraft and Gene Kranz had on your career as a flight director?
Well, I have to separate those because Gene Kranz was more of a peer. He was my boss because he ran the flight director office, which was an administrative role. And Gene and I are still good. We're good friends and highly respect each other. Kraft was one of the most interesting people I've ever met in my life. He had a way of, he called us all young man this, young man, do something. He was only about 10 years older than I was. But true leadership is interesting because a leader to me is someone, Chris, not only did we respect him, we wanted to make him look good. I don't know if that makes sense, but we wanted him to be proud of us because we were good. But we really wanted to do well so that he looked good. And he was that kind of magnetic force around him or something that when you got around him, even to the day he died, and we were good friends, I always felt a little bit in awe of him and I've never felt with that way with anybody else at NASA. But Chris brought out that feeling that do your best for him, do your best for him, make him happy, make it pay off. And when it did, it was a wonderful feeling. And I think that's a measure of a true leader. Kranz is, by the way, is more, we called him off and on the Prussian general because he still has the crew cut, which is more than I've got. But he's still got the crew cut, and he was kind of a very militaristic style speech and all that. But Kranz was good. And he, the funny thing, I can think back, and you all, most of you, all of you are going to line up in the same position someday where we're working 24/7. If you have to do it, you just do it, and you enjoy it. I've never enjoyed anything more in my life than walking in that control center. It's like walking into a cathedral and you were going to give the sermon. It was really a special feeling. And I told people, and I tried to get in all the movies I worked in when they showed control center scenes. I said, you see all of us in the real pictures, and we got these stern looks on our face, and like that one with Kraft talking to me. By the way, we never knew those pictures were being taken. Those cameramen got so good they could sneak around and take pictures and videos of us. I never saw them because you were too focused on what you're doing. But I told people that you see us, we got these real serious looks on our face. And yeah, it was serious, but it was a hoot. I said, I just have to tell you, it was so much fun. The challenge is what made the job so fun. And what happened in the control center is that we had a number of people that self-eliminated themselves. The pressure was just too much. I don't remember anybody that got removed from the control center because they weren't getting it. But a number of guys did say, hey, I just seemed that the pressure was just too hard. But most of us thrived on that. That's what made it fun, the pressure and the being out on the end of the diving board by yourself and with nobody around, and you had to make the decision. It's like when go on to the moon on Apollo 12 or come home. Let's go, but you did it based on good input, but it's just, God, it was fun. Always fun. And long answer. Another long answer.
Yeah.
My question for you was actually, would you like to go further with the questions? Or?
Would I like to go?
Yep. There are a lot of questions still.
Oh, yeah, sure. I would go anytime. Just tell me when to report.
Sure. Okay, well, let's go for another voice question then. This one is from George Lewis Lamb. George, you are...
Hi.
Yes, you're on.
All good. Okay. Hi, Gerry. Thanks for the talk.
George?
I'm a master's student myself. And as one of the guys in mission control, I was wondering what your thoughts were on the future of mission control and how its mission is changing with the autonomy. I mean, Dragon on Saturday, it's going to go and dock itself. It's a step process. And mission control, I guess their mission must reflect the change with the technology. So what's the future of mission control in your opinion?
I think, you're hitting a good note. It's going to change. It won't go away. But there's a lot of reasons it's got to change. One is the technology in the cockpit is better. The Dragon, if you notice it, do all touchscreen. It was all touchscreen controls, and where's the switch, that you actually have to trip, or a circuit breaker you got to push in. But that technology is really good. And I haven't figured out what they were going to do, if they have a big glitch in the system where they probably got it triply redundant or something. But there's going to be a lot more capability on board. But they're still going to need help particularly when it comes to the off normal situation. As long as things are plodding along, it's going to be okay. And they could probably almost do it with just somebody talking to them or what's wrong. But when things start to go bad is when you need the ground. And we proved that more than once in Apollo. Shuttle did the same thing. Shuttle pulled some irons out of the fire. I wasn't around for those, but I really think that and then you throw in Mars, and that's going to be entirely different, because at Mars it takes 16 to 18 minutes, depending on where the planet is, to get a voice transmission in one direction. So you ask a question, and it takes 16 minutes to get there, and they answer, and it takes 16 minutes to get back. But you're not going to be able to help them with anything like Apollo 13, with the tank blowing up. They're going to have, and we've already talked, I've talked to some of the people at JSC. They're talking more about, first of all, you got to have more diagnostic capability on board that's running all the time, and you run diagnostics constantly to make sure the power system, blah, blah, blah. And you got to have more tools, both physical and software tools, to help if you get into a bad situation at Mars, 16 minutes away, one way. So it's going to be an entirely different operation. I think the ground in the Mars mission is going to be mostly planning stuff and streaming it out to them. Today we want you to go to point X at the bottom of the hill and so and take a sample of something. And it'll be a planning tool or a flight planning layout, and then you're going to have to come home eventually, and your device is not now. Okay, it just told me I had to sign in to something, and I knocked it off. Mission control is going to change a lot, and it's not going to take as many people, probably. Even the ground systems are much better. Everything now is just. Let me tell you what we had in the control center in Apollo. We had 5 IBM 360 Block 75, 360 Block 75. Those were the best computers IBM had. And one of those computers would fill up most of this, and it was big stuff, and it required a lot of air conditioning, and you walked into those rooms and it was like walking into a refrigerator. And we had 5 of them, and not one of them has as much as my cell phone had in capacity. So that's how far we've come, and the ground systems now are all dispersed. We had everything that we did came through we had an IBM 360 online. We had a running standby that was parallel, and the other 2 were used for other purposes, unless we had to have them on the mission. So we had one computer that we had to tell people so they could, if we wanted to change something on our display, we had to give it to somebody, and they had to punch out punch cards, and put it in the computer. Nowadays, it's all dispersed. The flight controller in that space station picture you saw, they can actually change their own displays in real time. I don't want to look at that voltage anymore. I want to go look at something else. And so they just take it off, and they could switch back and forth and do all kinds of things. So I don't know exactly what it's going to look like, but mission control is going to be a lot different, and particularly a lot different in deep space.
Yeah, thanks for the answer. I think the delay is the most interesting part, as you picked up on. So thank you.
Yeah, and even at halfway there, when you're halfway there, it's still going to be 8 minutes or something, 8 or 10. So, okay.
Right. So the next one comes from Saurabh Chowdhury, and he asks, Sir, if we ever met or discovered life outside of Earth, how do you think NASA/humanity would react to this?
I think it would make the budget a lot easier. First thing. In fact, I've been hoping that one day, I don't know if any of you are familiar with SETI. SETI is Search for Extraterrestrial Intelligence, SETI. And it's done with a huge bank of antennas that are at in New Mexico. Arecibo has one, big one. There's others around the world, but most of it's in New Mexico. And it's kind of like the movie Contact starts with that premise. That's where Jodie Foster is. And they're listening for any intelligence signal. And I've been hoping for years, it's probably not going to happen in my lifetime now, but it's that they would get a hit where somebody would make contact with us. And then I think you'd see the space budget really go up for deep space exploration, because maybe there's somebody out there that could help us and we could help them, or vice versa. And so I really think that Jodie Foster in the movie makes, and I don't remember the numbers exactly, but she makes the point about extraterrestrial intelligence, that there is, she states how many known stars are in our universe, how many in our galaxy, and it's just one of them. I mean, it's billions and billions. There's got to be somebody other than just us out there somewhere in some form. They may not look, that has some sort of brain power. And it's just got, the numbers are just staggering. So I think it's going to happen, and I hope it does. I hope it does. I'd like to be alive when that happens and see how people, they, oh, all this looking you've done all these years, you finally found something.
Thank you.
We also had a question about whether, I mean, many people ask the same thing, if you need to be a US citizen to be able to join NASA.
The answer is yes. Now, but there's different ways to join NASA. NASA is more than just NASA. The agency, like for instance, that the number of NASA jobs at the Johnson Space Center when I was there was 3,300. And we had, when I was there, we had Grumman all around us. So, and all of them, we worked side by side with them. So not everybody has to be a NASA employee to work on NASA programs, if that makes sense. Same thing with ESA. You know, ESA, you've got the agency, and that's one thing. By the way, your major control centers are up at Noordwijk in Holland. Been there, and very, very nice facility. But your companies, you know, the French companies, the German companies, UK companies are all quite capable. And that's why I think, had we gotten to the international model earlier, particularly for deep space, it makes a little more sense maybe to go it alone. But the International Space Station has worked well with a lot of international partners. And but I think there's going to be opportunities to be in space and space technology from a lot of angles. See, we haven't even seen yet a European purely commercial company like a SpaceX, but there's going to be one, and there's going to be two, then there'll be three, and then there'll be four. There are going to be commercial space companies in the European Union. Does that still exist? I can't remember, but I'm just kidding. Brexit being what it is, and so anyway, I don't get too hung up on NASA, being NASA only. Now, they do have exchange programs occasionally where they will have an employee of visa and employee of NASA swap, kind of like a military Italian fighter. An Italian guy comes over here and flies an American fighter for a couple of years. And so there are those kinds of things. But don't get too hung up on just NASA, because NASA, it's not going to be just NASA that does it. And it's not going to be just NASA, not just US of A that does it. That's my answer.
Yeah, I actually wanted to point out to the people that are dreaming about NASA, but you also mentioned ESA, the European Space Agency. And for example, in my experience, a lot of the contests for students, for example, that NASA had, ESA also had the equivalent. So I always looked up on both websites, and I used to participate, in the contest that NASA had and in their equivalents in the European Union. And they're particularly, they're the same. So yeah.
Yeah, and ESA, European Space Agency, has had a number of astronauts fly. They just haven't flown on an ESA launch vehicle. They've flown on shuttle. They're going to fly on the SpaceX and Blue Origin eventually. And so yeah, I think there's going to be a lot of opportunities that if we're going to have to, I think we're going to have to lead the way in the U.S. So the eyes are going to be on Biden administration to see what they do. And hopefully they'll keep going.
Yep. Thank you very much for the answer. Now let's go next to someone who raised a hand. And my apologies if I pronounce the name wrong. Is Eastway Geoffrey or Jeffrey? If you could, Nikita, unmute him.
Hello?
Hello.
Hello, my name's Geoffrey Eastaway. I'm phoning via, I suppose, the Royal Irish Academy and Cork Astronomy Club. And thank you very much for a wonderful, wonderful talk. I was fascinated with your comments about leadership. I'm very interested in technical leadership. I have been for years, and I wonder if you agree with me that technical leadership is not just the CEO, is not just the director, but it's all the way through the organization. It's such an essential skill, from your graduate engineers down through your supervisors and craftsmen and the people who do. For what I believe is largely a young audience, and also for my fascination, are there traits of leadership that you look for in your graduate engineers, rather than the sort of slightly nebulous ones that you've spoken about the wanting to please some, a person who has some intangible, trait? Are there traits of, I don't know, technical excellence or humility or that sort of thing that you would particularly look for as a senior leader in a technical field?
Well, the first question, I couldn't agree with you more that leadership qualities have got to be shown throughout the organization. It got to start at the top. And I used a word earlier that I think is leaders have to trust. They've got to be trusted from above, and they got to trust the people below them. And so many times, I think what I'm seeing now, and I see it in NASA, I see it, is that tendency is to suck decisions up higher as if they can be made better by somebody that lives inside the Washington Beltway. there's a lot of decisions at NASA being made. Not say a lot. There are too many decisions today being made at NASA headquarters, as opposed to the field centers. The strength of NASA is not embedded in Washington, D.C. It's in Houston, it's in Huntsville, Alabama, it's at the Cape, it's at the Jet Propulsion Lab in California, it's at the Langley Research Center in Virginia, on and on and on. That's the strength of NASA. So I think any organization has got to get all of that strength out. You've got to let them into the show, and not a top-down, and I think I know what you're getting at. In a technical setting, if you get a top-down leadership that starts at the CEO and just pushes everything, this is the way we're going to do it, you're going to wind up with a failure on your hands, because you're only good as that one guy or one gal. And you've got to figure out how to get all of the people involved as a part of it. And I think a leader understands that first. He understands that I'm not going to do this. I'm not in here to make a power play. I'm in here to get a job done. And I'm going to need everybody in this organization, not just me and a couple of other cronies that are going to figure everything out and tell people what to do. So I think, and in leadership, I think that I look for is that people that are willing to listen and particularly develop other people, and not be afraid to give credit. I love to give credit and say, Lucia is amazing at setting up Zoom meetings or something. That makes me, and by the way, I believe that, but I think it makes a lot of difference to people to be appreciated. Now, I'm not saying carry somebody along if they aren't cutting it, but if they're getting the job done, develop them, bring them along as you grow, and as you learn things, share it with them, and then go to a pub and have a good cool one with them, and you can kind of seal it off. I see that Saturn V over your right shoulder, and
you're never too old to get a good bit of Lego, and that was my my son's Christmas present.
Okay, well, I've got a big one, but it's set up too high. I didn't want to get it down.
I utterly agree with what you said about listening, growing people on, and have sadly in my technical career seen too little of it. It's a message that I hope your younger listeners will really take to heart. Thank you so much. And if you ever find yourself in Cork, give us a shout and let's have some Guinness.
My family came from County Cork.
No, really?
Yes, right.
Thank you. Okay, right.
So well, good. Thank you.
Right, so the next one comes from Emilia Ramirez, and she asks, hello, I would like to ask something. Life is overwhelming the way it is right now. What does it take to do what you did? How did you cope with the stress or anxiety, if you ever had any? And what kept you going?
Boy, that's a big one. I did have a lot of stress. I'm thinking back, even in the Air Force, it was in a pretty risky business. But there was, I think part of it was preparation that I had in college at Texas A&M. I was in the Corps of Cadets. I was in military, even in high school, they had junior ROTC, and I took it there. So discipline was kind of a strong thing with me. It still is. And I like preciseness and all that. But I think there was something that in the space business, it really brought it out that, we can do this. It's not going to be easy. And we had that leadership that we were talking about just a while ago, that turned us loose and let us do it. And I can remember going home at night during the middle of a mission and getting a good night's sleep. Now, Apollo 13 wasn't that way, but on Apollo 13, I got off shift. My gold team finished, and Gene Kranz's white team came in to relieve us. And I went out to play a softball game. Had on my sweatsuit and all that, and they came out and got us. And I went back into the control center. The first time I went in, I still had on my softball clothes, and I could tell right away that I better go home because I had to come back and relieve Glenn. When I left him with a perfectly good spacecraft, and he blew up the oxygen tank while I was out playing a softball. But when you live in a high-risk environment long enough, I think it either drives you away from it because you just don't like it, or it kind of sucks you in. People ask me, what's the best job you ever had in your life? And I said, when I was a flight director in mission control. And I mean that. And I've held some big jobs after that they were good, they were fun, but nothing like the exhilaration of beating it down and doing a tough job and getting it finished. And it was risky, and we lost some people. We lost 3 crewmen in the fire. I lost good friends in the Air Force. So I had a little bit, and if you're going to be in that business, you have to have a little bit of scar tissue. I mean, it's not like the world comes to an end. It's a risky business. People have asked me, what's NASA's primary purpose? And I said, it is to manage risk. You manage it as low as you can, but you're never going to manage it to zero. Same thing can be said of getting out of the M4. You certainly want to manage the risk to zero, but you can't. You just can't. It's always going to be a risk when you get out there on the A4, maybe. That's it. The stress has never bothered me, and I think it was just because I was kind of pulled into the high risk stuff.
Okay, thank you. Maybe a couple of more. So I see Rai has his hand up. Let me just. Okay. Second. Okay, nope. Then let's go with Raj.
Hello, sir.
Hello.
Yeah, I wanted to ask, like most of the satellites are orbiting in the lower Earth orbit, right?
Could you repeat that? I'm not sure I understood the question.
Okay, so I wanted to ask, why are these satellites orbiting the lower Earth orbit instead of the higher Earth orbit, where the orbital velocity requirements are low?
If I understand your question, why do we stay so low and not get up higher? And it's all a matter of energy, if that's the question that you've asked. To get a mass to a higher level, particularly like one like the shuttle was carrying up to the space station, they built that at around 200 miles, something like that, and then boosted it up to 250 for operation. And but there's just not enough propulsion. You could build a smaller station probably and go higher, for instance, or you could put it in an orbit that maybe is not so circular, maybe more what we call highly parabolic, with a low perigee and a very high apogee, low altitude and high altitude. But you still, every time you come through that low altitude, you get drag, and so it starts lowering the higher. And I probably didn't make much sense with that, but the operation at different altitudes above the Earth, particularly, are very highly dependent on how much energy you have to put them up there and maintain them there too. The one thing about space station, which is kind of unique, is that a lot of their studies are Earth oriented, so they don't want to get too far away, or it makes that not quite so good. And so I hope I answered your question, but I may not have.
Okay, thank you very much. We have one more question that is more personal. I've seen a lot of questions like this. One of them would be, how much does the university you study at undergraduate level matter when it comes to pursuing a career in aerospace?
An undergraduate level degree from my university is absolute, and others like us, University of Texas, and Stanford, and any of them, are absolutely essential. Now, having said that, it depends on what level you want to go to. Now, I know most of you, or all of you, except maybe some that have already finished, are in college, or maybe if there's a high school student around you, you intend to go to college. And I would highly advise you to do that. But one of the shortages that we have in this country, and I think you've got it too, is that we are losing our tradesmen, tradecraft, people that can build things. And so I don't put anybody, if somebody wants to be a precision welder or a precision build up electronic components, or somebody that does wiring for complex machines like a spacecraft, we've got to have those kind of people too. And I really, in Texas, I can tell you, in the state of Texas here, I was on the Texas Higher Education Coordinating Board, and for years, of course, the promotion was higher education, university, graduate level, undergrad or graduate level, on undergraduate and graduate, on. And toward the end of my term, as governor appointed by the governor of Texas, and I served a 6-year term. Toward the end of the term, we started using a new term up through the end of high school. And so rather than talking about only higher ed, which we universities, we started emphasizing post-secondary education. Post-secondary includes certification as physician assistants, whatever, but things like welders and all that with it, because that part of our workforce is slowly going away, and we've got a large uneducated workforce that some didn't even finish high school, that we need to bring along. And if they're not interested in university, look, we can find you can find a field of your choice that you might work. So I would encourage everyone to go to college. There's more to college, and you folks are experiencing it right now. There's more to college than just learning what's in the books. It's relationship, except when you have a pandemic. It's relationships with other people. It's working as a group, working as a team on certain things, and which the pandemic has really made it difficult. But college, I think, has a lot more to it than just books and learning. It's maturing, and it's a confidence builder that is so important. And particularly if you're going to go into, I know a lot of you, I know Lucia at least is a computer science major, but I bet a lot of you are technically oriented. software, something like computer science or something. And those are so important. You've got to finish and then opportunity for the future.
Thank you very much for this very nice answer. And there are a lot of people that ask you why you did not go into space. You tried to cover a little bit during the presentation.
Yeah.
But
Well,
in particular, you want to know why.
I was a little bit out of sync with when the original 7 astronauts were all test pilots. And just like in the UK, you have test pilot schools that they actually went to. We have a Navy test pilot school, we have an Air Force test pilot school. All of them were graduates of that school. The second group was the same way. That's about the time I came in. There was no way I was going to compete with those people. Now, toward the next group, the third group, if I had decided, I might have had a chance, although I doubt it because they were looking for scientists. And the scientist, they actually met, is a lunar is geologist. And, but they weren't looking for other pilots. They had plenty of pilots and plenty of mission specialists, which were kind of like flight engineers, and but they wanted some scientists. So I really think I went for it because I knew I could do it, and because of my background in engineering and flight, and but I would go. People back when the shuttle, right before the Challenger accident, this was about a year before it, and that's when Krista McAuliffe, the teacher, was selected to go on the flight of Challenger that exploded. And but they were going to fly a teacher, they were going to fly an entertainer, they were going to fly a journalist. And I worked with John Denver, who was a good friend, singer, and he was also a pilot. And he was really going to try to be the entertainer. And I helped him write his letter to, well, I wrote a letter to the administrator, the head of NASA, and said, I ought to go because I was the center director at Johnson Space Center then. And I said, I ought to go because I manage all of these astronauts and all that. And I need to know what this is really like. I need to experience. So you ought to have a category called NASA management that over time you would fly 1 or 2 or 3. And with my flight background and all that, I would be perfect. Well, shortly after that, then the Challenger accident happened. And so that program was put aside. But I have told people, and I mean it as sure as I'm sitting here right now. If somebody asked me if I would go, right now, I'd say, yes, send me, I'll go. I'd love to. The risk be damned.
Okay, thank you very much for this. I think we will go with 2 more questions and wrap it up because it's a little bit late. So from the people who have raised hands,
I'm about to get talked out. Yeah.
I do understand. Let's go with Atharva Anand. Nikita, if you could please unmute.
Hello, sir. My question is that are there any upcoming space missions that mainly will focus on reducing the space debris, as these pose great threats to the satellites and the telescopes in orbit?
Yeah, big problem, and what he is alluding to is the extreme amount of junk that we produced in space, particularly in low Earth orbit, where there are still spent launch vehicles, dead satellites, but then an awful lot of little pieces of debris that were caused by, in the old days, we used to use a lot of explosive bolts to separate modules of a spacecraft or something like that. And those would spew out pieces of debris. And in fact, we took a hit on one of the shuttle landings, or it happened in flight, but when they landed, the windscreen on the front of the shuttle that they looked out was about 2 inches thick because it got hot up there. And there was a penetration that went in about 1/2 inch. And they later turned out, when they got it on the ground, analyzed it, it was a chip paint, but the velocity was so fast that it actually penetrated the glass about 1/2 inch out of 2 inches. So you can imagine what a big chunk might do if it hit it. There's a lot of studies going on right now trying to figure out how to clean that mess up. And there's some pretty good technology that's starting to show up. Some of it even involves going out with something and throwing a net over this thing and bringing it. These are robotic spacecraft that do that. Throw a net over this spent satellite and then deorbit it. And it burn up. It'll burn it. It doesn't have a heat shield, so it can't make it through the atmosphere. But then there's all these little bitty pieces, and that's going to be a real problem. And they've tried to figure out, well, would magnetics work? Probably not. It's too much, stainless steel and metals that would not attract to a magnet. But it's a mess, and it's particularly a mess at 21,000 miles, 21.5. That's where the geosynchronous satellites are, the communication satellites. That their rotational rate around the Earth at the equator is the same rate that the Earth is rotating. So it appears that it's fixed, and that's how you get a relay satellite up and down. And those at that 21,500, there's been so many satellites put up there. Some are derelict now. And they've also had, maneuvers and things like that have not worked right, where they lost parts off of them. And so 21,500 is kind of like a junkyard. And then there's more. Then there's some more at low Earth orbit, more around the 100-mile. But it doesn't stay there very long because the atmosphere will finally suck it, slow it down enough that it falls down. But you're hitting on if you read the journals of spaceflight of all kinds, there's a gazillion of them. That's in every one of them. Almost every month there's another worry. And the space station has had some near misses, and they've had to move the space station a couple of times because they could see coming up that there was going to be a 4-foot section off of something or other that was going to collide with it. So they would make a slight maneuver early with the station and to make it miss. And then finally there's at NORAD, it's called North American Air Defense or something. It's the radars. They can track everything in space, every particle in space, down to about something the size of probably a cricket ball or something that size. They can track all of that debris, and it's just everywhere. So it's going to have to be a problem that's dealt with. Good question.
All right. As one more, just to kind of wrap up, it comes from Padraig O'Meara, and they ask, what life advice do you give to your own children after everything that you've done and experienced? It's for my nephew, Sam. He is obsessed with space exploration.
Good. Okay, that's a good one to end on because, we've got 2 kids. We moved all over the U.S., and it's kind of like a military family. Sometimes that works and sometimes it doesn't. in our kids' case, they got to meet presidents and heads of state, and both of them have just turned out to be wonderful people and both successful business people. And in fact, our daughter owns her own public relations firm. Guess what? Most of her clients are aerospace clients and marketing and public relations. And she's in Houston. We're about 300 miles away. I think, the best example, I think the best thing to do with your kids is to give them a good example to watch and see. And I think both our kids, I know, watched both of us carefully, I guess, because my wife Sandy and I, we were doing this at the same time. And I didn't get to see many, Little League ball games or Boy Scout meetings and all, because she was having to do that. We were working weekends and everything else. But when we got together, it was fun time. We went camping in mountains of Montana and all kinds of things. When it came to education, I think they kind of picked it up on their own. It was never any question that they were going to go to college. It wasn't even much of a question of what they were going to study. So it didn't take much advice there, let me say it that way. But I think the thing that I probably came to, what built my career was my willingness to make change and go somewhere else and try something different. And there was a clock, must have been an unconscious clock in my head. About every 4 years, it seemed like I had kind of, I figured this attitude, I've kind of figured this out. What am I going to do now? And at each point, there was a break that fortuitously happened. I was 4 years in the control center as a Gemini flight controller and got that done. And lo and behold, I was getting ready to do my 5th year as in the same position for Apollo, and the fire happened. And during the break, 21 months of break between there, Craft decided he wanted another flight director. So I had a new job, new set of things to do. And I did that for 4 more years, from 68 to 72. And then I get a call that says, we want to talk to you about coming to Washington to work with the Congress. And I thought, what? I was 38 years old. And I was a Texas A&M aeronautical engineer. I didn't know anything about Washington and how the Congress clicked and what made it click. But the more I thought about it, one of them talked to the head of the agency, and they said, we need somebody that can explain the technical stuff to members of Congress about the shuttle, to keep it on, to keep it going. And so I said, okay. And I came back and talked to Sandy. You want to go to Washington? Yeah, let's go to Washington. Off we went to Washington. And I did that for about 4 years. It drove me nuts, being inside that bubble of crazy stuff with congressmen. But I wanted to get out of there because I could sense that it was pulling on me. Boy, this is really a neat place. You go to a White House dinner, or you go to a reception on the Hill with all the congressmen. Ah, man, this is really it. Yeah. They're not making anything happen. I wanted to get back to the real world. So anyway, then I went and did some other thing, came back to finish up at JSC. My point is all this. I think one of the biggest pieces of advice is that don't be afraid to make a change. And obviously, the biggest change I made was going to Washington. The other changes were easier because it was more management by that time, but it was management of technical stuff that I knew. Washington was a complete change. And let me tell you what happened. Going to Washington broke me out of the pack. I was one of the few guys that ever left Johnson Space Center. It broke me out of the pack. I got new exposure. I got exposure to other centers of NASA in a lot different light. And when I came back to the Johnson Space Center, it made me a better center director because I understood the other centers and their capabilities a lot better. And I understood what went on in Washington. So, bottom line, don't be afraid to make a change. Don't get wrapped up in the geography of where you are or where you want to be. I wanted to be in Texas, and I finally got it. But you can always make that happen. But follow the trail where the path leads you, and don't be afraid to make the change.
Thank you. Thank you very much. And on that note, it's probably best to wrap up. We've been going for 3 hours straight.
Yeah. It's almost beer time here, and it's past your beer time. So
yeah, definitely. So yes, Mr. Griffin, thank you so much for joining us, and for giving this speech. I can see everyone's writing, just the best stuff. Thank you.
See that. I see those too, and I appreciate every one of them. And I say again, my pleasure, and thanks to Lucia for stepping up and sending me the email to say, come on. And
it was my pleasure. You're a really inspiration for me. And ever since I listened to you in the conference, I really want to ask you some questions. I really want to find out more about you and how you work with NASA. And I never had the courage somehow to actually approach you, but I'm very, very, very glad that I did it. So
okay.
I should be the one. Thank you.
Remember Mission Control.
Yep.
There it is.
Hopefully we'll be able to do some really nice things ourselves as you did.
Well, if I get to when I get to the UK, I'll have to look you up. And I told Lucia in a private conversation earlier that London is the whole UK, but London is my special love, and I've been there a lot. I know it well. I finally year before last, I finally made Wales, and had a very nice time out there. I've been to Ireland and Scotland and UK, England a lot, and it's a wonderful place. I look forward to seeing you in a pub in London.
Well, I hope that once this whole global situation with the pandemic is over, maybe you might be able to actually come to King's and have an event.
There you go. I'd be glad to.
That would be absolutely lovely.
I'll be glad to. We'll work it out.
Of course.
Okay. Well, thank you for your attention. And my voice is starting to get a little needing some liquid other than iced tea. So, okay.
All right. Thank you very much. And,
ciao. See you later.
Bye.
Okay.
Thank you very much once again.
Thank you, guys. Okay.
Have an excellent day. Goodbye.
And just before everyone quickly hops off, I'd like to say a big thank you to the collaborating societies, in particular, Imperial Robotics Society, the KCL Tech Society, of course, UCL Space Society, UCL Tech Society, one second, as well as KCL Engineering Society, Women in STEM Society, the KCL one, Oxram, KCL Machine Learning, KCL Blockchain Society, and of course the Manchester Robotics Society. And again, guys, this will be uploaded to our YouTube channel, so please stay posted. We'll ask the collaborating societies to possibly also post that link out. And yeah, that should be done within a week or so. So thank you all very much for coming along. And please get yourself a membership. It actually helps us quite a lot. We can then bargain with KCLSU and the rest of the bureaucrats at KCL that actually try to sort of make this stream not happen. So yeah, please do that. And yeah, thanks to the KCL Robotics Committee, especially Lucia. She's helped out a lot. She's, reached out to him. He said yes, and great help. Also to Christopher, to Joey, Sartak, Pratibha, Pratyaksha, and yes,
Natalia,
Natalia, of course, and Moni. Right, there we go. The entire KCL Robotics Committee. They've all been a massive help. So thank you all for coming, and have a great evening.
And possibly see you all at another event. Maybe we will do something else in the future.
Yes, and if you want to polish up on your engineering skills, we will be having an event next week on Saturday on how to use an Arduino. That is also upcoming. And then the week following that, there possibly will be a Python tutorial, just a beginner's Python tutorial. So yeah, please stay posted. All right. Thank you, everyone. Goodbye.